All right, on the quiz, theorem. Theorem is just a mathematical rule. Mathematical rule that must be proven true. Remember, a postulate or an axiom or corollary is a mathematical rule that we just take for granted is true. Midpoint, point that splits segment into two congruent segments. You didn't know that, so we're on the sideboard over there. Supplementary angles. Make sure with supplementary angles, first part in here, two angles that add up to 180 degrees. Supplementaries, two angles that add up to 180. Complementaries, two angles that add up to 90. All right, on the notes, congruent polygons. Congruent polygons, if you didn't pick up notes, grab them, start filling in stuff, what we're going to cover. Identify corresponding parts of polygons. Use the corresponding parts, and then there's a theorem that we're going to go over called the third angle theorem. Corresponding parts, all corresponding parts are if I give you two polygons and they're congruent to each other. So let's say I have this pentagon and I have this pentagon, and I tell you that they're congruent, then you got to match them up. So we may have to spin this around or something, but whatever sides match up, so let's say maybe this side ends up matching up to this side, those are corresponding parts. Maybe this angle matches up to this angle, those are corresponding parts. That's all they are, is the parts that match up when you lay the two congruent polygons on top of each other. Most of them that we deal with are going to be triangles. Fill in what you need to fill in on this. This is some big words here. We're not going to do a whole lot with it. All that means, principle of superposition, is that you take the two shapes and you match them up to each other so that they line up perfectly. And we do that by doing our transformations that we talked about. Could be a slide, so I could take this triangle and match it up with this triangle by just sliding this one over on top of it. It could be if I take this triangle and maybe I have to, oops, I can't draw very well, match it up to that triangle, then I might have to flip it over, a reflection. Or it could be that I take this triangle and I have to match it up to some triangle maybe like this one, and so I might have to rotate it around to get it to match up. You're just matching them up. Some theorems and postulates that we need to know that we're going to use a lot. Properties that work for triangles, we're going to use them a lot with triangles. A lot that we do from here on out is going to be dealing with triangles. Reflexive property. Reflexive property, again, remember, is anything equals itself. Got to know that from here on out. Symmetric property. These are all properties that we covered earlier this year for segments and angles and all the other stuff. Symmetric property, remember, all symmetric property does is it switches the order. So if you have to switch the order to make it the correct way, then you're using symmetric property. And transitive property just says if this triangle is congruent to this triangle, and this second triangle is congruent to some third triangle, then that tells us the first triangle and the third triangle have to be congruent to each other. Remember, with transitive property, this middle thing here has to be the same in both statements. So if these two are the same. This one's congruent to triangle ABC, and that same one's congruent to triangle HGR. And that means triangle ABC and triangle HGR has to be congruent. The other thing that we could use in place of transitive property, remember, because we didn't use transitive property very much, is substitution property. We just take out one thing and substitute something else in its place of equal value. Two-angle theorem. Two-angle theorem says if blank of one triangle are congruent to blank of another triangle, this should say if two angles of one triangle are congruent to two angles of a second triangle of a different triangle, then the blank of the corresponding angles must be congruent. Then the I sort of wrote this wording so it confused me for a second. The rest of it says then the third pair of corresponding angles must be congruent. I made it harder than it has to be. All it's saying is if we know angle 1 is congruent to angle 4, so those two angles are congruent. Angle 2 is congruent to angle 5, so those two angles are congruent. Mathematically, the only way that this works out is for these third pair of angles to be congruent. So in the blank right here, that tells us that angle 3 has to be congruent to angle 6. So if you know these two angles are congruent to these two angles, then that means the third pair of angles have to be the same. Next, if two angles are congruent, two angles are congruent if and only if two triangles are congruent if and only if all the corresponding parts are congruent. So all that's saying is if I have these two triangles, the only way that these two triangles are congruent, if these sides are congruent, these sides are congruent, these sides are congruent, this angle is congruent to that angle, this angle is congruent to that angle, and this angle is congruent to that angle. So all the parts have to match up for them to be congruent. Corresponding parts are the parts that lie on top of each other. So if I took this triangle and I was trying to match it up to this triangle, this part, if I just slid this over, would lie right on top of that segment. Those are corresponding sides. This angle would lie on top of that angle. So those are corresponding angles. That's all corresponding parts are. And we're going to do a lot with corresponding parts as the chapter goes along. The congruency statement. A congruency statement is when you say two things are congruent. And what we're going to say here is that these two triangles are congruent. When you do the congruency statement, you've got to make sure that you match them up correctly. So you've got to make sure that you match them up right. The first triangle, it makes no difference how you name it. So the first one, I'm probably going to name it triangle ABC, just because that's easy. When you match them up, you got to make sure that the first letter in this triangle matches up to the correct letter in this triangle. I look here, angle A has the one arc in it, so it's got to match up to the one arc angle in the other one, which is angle W. So that has to come first. Then I got B. B over here matches up to T over there. So T has to come next. You have to make sure you match them up correctly. And then C has to match up to D. There's other ways that we could have named those two triangles, but you have to make sure that A matches up to W, B matches up to T, and C matches up to D. And then what that tells us, when we know that those two triangles are congruent, we know that all the sides that match up are equal to each other, and all the angles that match up are equal to each other. So if I pick segment AB, I can look at the names. Segment AB, that's these first two letters. That means it's got to match up to segment WT in the other one. And that means that they have to be congruent. So that's the first thing to put down there. Or I could look at the triangles and see how they match up. So if I look at the triangle and I pick segment AC here, segment AC has to match up to segment WD in the other one. And then the third pair of segments, or the third pair of sides that match up, segment CB. And it doesn't matter if you name it segment CB or segment BC. That doesn't matter as long as you match it up with the correct side in the other one, which is segment DT. So we know that all three of those pairs of segments are congruent. And then the angles, I'm just going to name the angles with one letter because I'm being lazy. So I know that angle A has to be congruent to whichever angle it matches up to in the other one, which happens to be angle W. Angle B has to be congruent to angle T. And the last one, angle C, has to be congruent to angle D. Oops. That's a D. That's an ugly D, but it's supposed to be a D. So anytime we know that two triangles are congruent to each other, then we know all of this information here that we just wrote down. All those pairs of segments are equal to each other, congruent to each other, and all those pairs of angles are congruent to each other. All the corresponding parts, all the parts that match up, are equal to each other. Lots of information. CPCTC, fill this in. All you need to really put in is the underlined ones here. That's what it stands for. Corresponding parts of congruent triangles are congruent. So if we have two triangles, and we know that these two triangles are congruent, then the parts that match up, like this part and this part, have to be congruent to each other. And this not only works for triangles, this could say corresponding parts of congruent polygons are congruent. So it works for any two congruent polygons, but the ones we're going to deal with most are triangles. So CP, CTC. This might be one of those things that we want to write over on the board as one of our commonly used reasons, because we're going to use it a lot. CP, CTC. We know that these two parts are congruent because they're corresponding parts in these two congruent triangles. So corresponding parts of congruent triangles are congruent. Open up your books to page 301. We're going to do page 301 together, and you're going to turn it in. So if you're not writing it down, you're messing up because it's a free grade. Number 1 says, show that the polygons are congruent by identifying the congruent corresponding parts. Then write a congruency statement. So in the book, it gives us this. That segment's congruent to that segment, so I'm going to just write that down here. Segment AC is congruent to segment BD. That's one of the things that they tell us. Then they tell us this segment's congruent to that segment, and that tells me that segment DC is congruent to segment AB. Then they also tell us that they actually marked this for you, but they didn't have to. And all that is, this segment is in both triangles. So we know since it's in both triangles, any segment equals itself. Anything equals itself. So segment BC is congruent to segment BC. So for those of you who were wondering when we were ever going to use anything equals itself, it's in stuff like this right here. That segment's in both triangles, so it has to be the same. So if I told you BC in the triangle on the left was 30 centimeters long, BC in the triangle on the right has to be 30 centimeters long. Then they also tell us that angle A is congruent to angle D. They have the little marks in here, so angle A is congruent to angle D. So right now we have all three pairs of segments that are congruent, one pair of angles. We need the other angles. Then they give us this information. They have 2 marks here, 2 marks here. We can't name this angle or this angle with 1 letter, so we got to name it with 3 letters, and we start DBC. So angle DBC is congruent to angle, and then this one down here is angle BCA. That's all the information they tell us, but we just had a theorem that said if these 2 angles are congruent to these 2 angles, then the third pair of angles have to be congruent to each other. So we can fill that in. So this angle is going to be angle ABC is congruent to angle DCB. And you can name it the other way if you want, it doesn't matter. So now we have 3 pairs of segments, 3 pairs of angles. That tells us that the 2 triangles are congruent. Now the last thing they want us to do is to write the congruency statement. So we got to name this triangle and match it up with this triangle and say that they're congruent. This first triangle over here, I'm just going to name it triangle ABC, just because that's easy, is congruent to triangle. We've got to make sure we match it up. A matches up to D. We put B second. B matches up to, B in this triangle matches up to C in this triangle. And then C in the first triangle, C in this triangle here, you got to be careful because it sort of switches them around. C in this triangle matches up to B in that triangle. That's our congruency statement. Got to make sure you can match them up every single time. Make sure, again, clean sheet of paper, you're writing this stuff down. We're going to go through it together, then you're going to turn it in. Sorry, I was trying to get rid of the ink. On the next one, remember that these arrows, these 2 tell us that those 2 are parallel. These 2 tell us that those 2 are parallel. I'm going to do the segments first. Make a little line over here. Know that we're on number 2. So segment KL is congruent to segment. These little tick marks tell us that those 2 are congruent. Is congruent to segment JM. That's 1 pair of segments. The double tick marks here and here tell us that those 2 are congruent. So segment JK is congruent to segment ML. And all we need is the third pair of segments, which in this case is this one right here in both triangles. So we know that segment KM is congruent to segment KM because anything equals itself. So we have all 3 pairs of segments, all 3 pairs of sides. Now we need the angles. Since these 2 are parallel, we can use this. Notice that forms a Z, so that tells me this angle has to be congruent to that angle. So that's angle, some of the stuff you got to come up with on your own over all the stuff that we use. So all those are alternate interior angles, and they have to be congruent. So angle LKM has to be congruent to angle KMJ. So that's 1 pair of angles. We know that these arrows tell us that these 2 are parallel. So I could do this. This one's parallel to this one. I use this as my transversal. Notice I form a Z again. So that tells me that this angle is congruent to that angle, and I'm going to name them. Angle JKM is congruent to angle LMK. Then we go back to that theorem that we just had that said these two angles are congruent to these two angles, then the third pair of angles have to be congruent in those two triangles. So angle K, and we could name these with one letter, and I'm going to just to be lazy. Angle J is congruent to angle L. So now we have three pairs of sides, three pairs of angles. That means the two triangles have to be congruent, and we just match them up. Triangle, I'm going to name this triangle over here on this side first. Triangle KJM, doesn't matter how you name the first triangle. What matters is that you match up the second triangle. K in this triangle has 2 marks on it, so it matches up to the M in the other triangle. J in this triangle matches up to the L in the other triangle. And M in this triangle just has that 1 mark on it right there, so it matches up to the K in the other triangle. That's our congruency statement. Now, as we go through this, it's a lot of writing for right now. We're not going to do this much as we go. We're going to learn some rules that's going to make this a whole lot shorter. Number 3. On 3 and 4, all we're going to do on 3 and 4, and you can change this in your thing, we're just going to mark them, and then we're going to name the congruency, the two triangles that are congruent, or the two shapes that are congruent. We're going to match them up. So I'm not going to name off all the segments and all the angles. We'll just mark them with how they show us, and then we'll match them up. So on 3, they tell us that this is 2.5 and this is 2.5. So those two are congruent. This is 4.3 and this one over here is 4.3. So those two are congruent. And this is 30 degrees. Put 1 arc in it. And this one right here is 30 degrees, so those two are congruent. This is 60 degrees. This one's 60 degrees, so those two are congruent. This is a right angle. That's a right angle. And we had a theorem that said all right angles are congruent, so those two have to be congruent. That's 5, so those two have to be congruent. And now all we're going to do is match them up. Triangle, I'm going to name the triangle on the left first. XYZ maybe. Again, you can name it however you want. On the other side, we just got to make sure we match them up. The X is the right angle, so it has to match up to the A. The Y has the 2 marks in it, so it has to match up to the B. And the the Z has 1 mark in it, so it has to match up to the C. That's our congruency statement. Just making sure you match them up. The next one, I'm just going to label the angles here. That's 107, that's 109, this is 108, this is 111, and this is 105. And the other one, this is 105, that's 111, this is 108, this is 109, and this is 107. And we just got to make sure we match them up. The first pentagon here, doesn't matter how you name it. So we'll say pentagon, and then just give the letters. There is no symbol for a pentagon, so we just have to write out the word pentagon, and we'll call it A, B, C, D, E. And it's going to be congruent to, and I didn't give myself enough space, so I'm going to write the other one down here. It's going to be congruent to pentagon. The A here is 109, so it matches up to the F. The B is 108, so it matches up to the J. The C is 111, so it matches up to the I. And then all it's going to do is it's going to continue around the shape. So the next one's going to be H, and the next one's going to be G. That's our congruency statement. Number 5. Number 5, they give us these markings. This angle has 2 arcs in it. This one has 2 arcs in it. This one R has 1 arc in it. J has 1 arc in it. And S has 3 marks in it. And L has 3 marks in it. And they tell us that TS is congruent to KL. That one has 2, this one has 3, this one has 2, and this one has 3. And we just got to make sure that they match up. We could name all the sides and all the angles that match up. We're just going to look at it and make sure that they do. So if we flip this one around and try to get it to match up, sort of spin it around, it looks like, and we might have to flip it also. It looks like we can name triangle RST. That's our first triangle. Doesn't matter how you name it. The R matches up to the J in the other one. The S matches up to the L in the other one. And the T matches up to the K in the other one. That's our congruency statement. Six and 7. Problem 6 just says find the value of X. Problem 7 says find the value of Y. They give us these two and they tell us that these two triangles are congruent to each other. So we just have to match them up. If we look at this, and we're going to have to find Y first, so we're actually going to have to do number 7 first. If I take this triangle and I sort of flip it over so that it matches up to the other one, notice that C here is going to match up to E, B is going to match up to D, and A is going to match up to F. Well, if B matches up to D, those two angles have to be congruent to each other. So Y for number 7 has to equal 48. Nothing really to solve there. Just set it up, say, hey, these two are equal, so they have to, if one's 48, the other one has to be 48. Here, if I know that this angle is 108, then that means angle E has to be 108. And I also know now that Y is 48, so I'm going to stick 48 right in there and get rid of that Y. And I know that this angle is 48 here. Then I know that the three angles of a triangle have to add up to 180. So I can say 2x minus 48, that's this angle, plus 48, that's this angle, plus 108 equals 180. And I know you could probably shorten that up a little bit, made it a little easier on yourself, because these 48s just cancel out. So now we got 2x plus 108 equals 180. Subtract 108 on both sides. We end up with 2x equals 72. Divide by 2. You end up with x equals 36. So that's right here. X equals, ignore that, 36. Eight and 9, same idea in 8 and 9. They just want us to find x and y. So 8, we're finding x. 9, we're finding y. I'm going to write those out here. 8, x equals 9, y equals, find y equals. So we look at this, we gotta match them up. We look at the names, gotta use the names maybe. Know that A matches up to P. So P is right here, A is right here. That tells us that A has to be 100 degrees. So to find x, we can set up this equation. 2x plus 4 equals 100. And then solve that. Subtract 4 on both sides. End up with 96 equals 2x. Divide both sides by 2. That tells us that x equals 96 divided by 2 is 48. So x equals 48. That's answer number 8. DC, that segment DC is right here in that first one. So it has to match up to segment RS in the other one, which is this. So if DC equals 3y minus 3, that has to equal 12. Has to be the same length as the one it matches up to in the other one. We add 3 to both sides. We get 3y equals 15. Divide by 3, and you end up with y equals 5. Number 10 and 11, same idea. 10, they want what x equals. 11, they want what y equals. I look over here. So I know that angle A has to match up to angle D. So A is right here, it's 65. D is right here, it's 2y minus 5. So I know those two have to match up. So 2y minus 5 has to equal 65. Add 5 to both sides. 2y equals 70. Divide by 2. End up with y equals 35. So that's the answer to number 11. I got y equals 35, so I'm going to get rid of this y right here and stick 35 right in there. Segment EF in this one, so that I can find x. EF is the last two letters in this one, has to match up to segment BC, the last two letters in that one. BC, that's right here. So 2x plus 35 has to equal this length, which is 90.6. Solve that. We're going to subtract 35 on both sides. You end up with 0.6. We have to borrow here. That's 5. Makes that 8. That's 55.6 equals 2x. Divide both sides by 2. And I'm just going to come up here. I don't have a calculator. So 55.6 divided by 2, 2 will go into 55 twice, that's 4. 2 will go into 15 7 times, that's 14. 2 will go into 16 8 times, that's 16. Comes out 27.8. So x equals 27.8. Number 12. Last one. Number 12 says, Camellia is designing a new image for her cell phone case. If the measure of angle ABC is 35 degrees, measure of angle BAC is 29 degrees, and angle ACB is congruent to angle DEB, what is the measure of angle DEB? So let's see if we can list all this on this picture here. It says the measure of angle ABC, that's this angle right here, is 35 degrees. So I'm going to write that in there, 35 degrees. As soon as I know that's 35 degrees before I go any farther, this angle down here has to be 35 because they're vertical angles. Those two angles are vertical angles. So just putting in stuff that I know. Measure of angle BAC, that's this angle right up here, is 29 degrees. Measure of angle ACB, that's this angle, is congruent to angle DEB. DEB, that's this angle. So we know these two angles are the same as these two angles. And those two this is a triangle, that's a triangle. Well, this angle equals this angle equals this angle, and that means this angle up top here has to be the same as that angle down there. So this angle down here has to be 29 degrees. Let's see what they ask us. Said find the measure of angle DEB. DEB is that angle. Well, what we can do to find that angle right there, we could have done it up here and just found this angle because they have to be the same. We have to take 29 plus 35 and we get 64. And we know that this is a triangle, so the three angles of a triangle have to add up to 180. So we just subtract 180 minus 64, we get 6, had to borrow there, 1, 1. So this angle has to be 116 degrees. Well, that means this angle has to be 116 degrees, and that's the angle that we're looking for. Make sure you turn those into the tray. Once you get back to your seats, start copying this down. Fill in the notes where you need to fill in. Most of the stuff that we're getting ready to go over is just review. We're going back over a whole bunch about isosceles and equilateral triangles, and that's what the homework's going to be over. I know we've covered this like 5 times now, but it'll all be stuck in your head then. Remember an isosceles triangle? Got at least 2 sides congruent. Those sides are called the legs. Third side's called the base. The angles that surround the base are called the base angles. They always have to be congruent. And this angle's called, if I could draw straight, this angle up top here is called the vertex angle. In the equilateral triangle, all 3 sides are congruent. And it's also got to be equiangular, so all 3 angles are congruent. Each angle is 60 degrees, we know that. So on and so on. And most of that's going to be on these next few slides. So in an isosceles triangle, at least 2 sides are congruent. In this picture, which ones are the legs? Which 2 sides are the legs? This time it would be segment AC, which is congruent to segment AB. Those are the legs in that isosceles triangle. Which segment's the base? That would be segment CB or segment BC, whichever way you wanted to name it. Which angle is the vertex angle? We could name it with 3 letters or 2 letters. I'm going to name it with 3 this time. Angle CAB. It's this angle up top here. The other way you could have named it was angle BAC. You could also named it just angle A. The base angles, those I'm going to name with just 1 letter. The base angles are right here. That's this angle and this angle. So it's angle C and angle B, which have to be congruent to each other. Next one, we're just going to fill this in. I know we filled this in a few times. If 2 sides in a triangle are congruent, then the angles across from those sides have to be congruent. And then the converse of that says if 2 angles in any triangle are congruent, then the sides across from those angles are congruent. So just fill in those. We've written them down a few times. We're going to start using all this stuff a whole bunch. That's why I'm trying to get it in your head now, because we're going to start using it to prove things. Remember, in an isosceles triangle, in any isosceles triangle, you got 2 sides that are congruent. The angles across from those sides are congruent. And that works for any triangle, isosceles, equilateral, whatever. If you have a triangle and you know two sides are the same, then the angles across from those sides always have to be congruent or the same. So if I give you a triangle and it looks like this, and I tell you this angle's 50 degrees, and this angle's 50 degrees, then that side and that side, the ones across from those, have to be the same. Equilateral triangle, we've already had this, fill in what you need to fill in. I'm going to go ahead and fill in some stuff on this picture. All the angles have to equal 60 degrees, we know that. Equilateral triangle, we just talked about this. All the sides have to be congruent. All the angles have to be congruent. That angle's 60, that angle's 60, that angle's 60. If a triangle's equilateral, it's got to be equiangular, and if it's equiangular, then it has to be equilateral. So if you know it's one, then it has to be the other. Some examples here. Find all the sides and all the angles. So if we have this, if this is an equilateral triangle, because we know all the sides are the same, then this side's 12 feet. This side has to be 12 feet. If it's equilateral, it has to be equiangular, so this angle's 60 degrees, that angle's 60 degrees, that angle's 60 degrees. This triangle's equilateral. We know all the angles are 60, so I'm just going to fill those in right now. If it's equilateral, then this side has to equal that side, so 4x minus 2 has to equal 3x plus 3. And we just solved that. Subtract 3x on both sides. We end up with x minus 2 equals 3. Add 2 to both sides. We know x equals 5. That's not what they ask us find. They ask us find each side, so I'm going to come back over here and I'm going to plug in 5 for x. So 3 times 5 plus 3, 3 times 5 is 15, plus 3 is 18. So this side's 18. Well, if this side's 18, then this side's going to be 18, and this side's going to be 18. On these, you got to sort of be able to split stuff off and look at it separately. And sorry, my segment symbols got moved here somehow. So they're supposed to be over top of those two letters. So if segment AE, that's on this side right here, I'm going to draw it off over here. Segment AE, A here, E here, is congruent to segment DE, that's the one on the other side over here. There's a whole bunch of triangles in this picture. We don't want to look at them all at the same time. They tell us that this segment is congruent to that segment. Then they want to know which angles have to be congruent. It's got to be that angle and that angle. And all of these I want to name with 3 letters because I don't want to get confused. So this angle over here I'm going to name angle EAD. EAD, that's that angle right there. The other one, go this way, EDA. Next one, if angle D is congruent to angle CED, then which segments are congruent? So I'm going to try to split off angle D. Angle D is this angle right here. It's on that side. And angle CED, that's this angle up top here. My picture doesn't look like this works very well. So angle D, that's this angle. Ignore all the rest of this stuff over here. We're just looking at this triangle now. That angle is congruent to angle CED, that's this angle. And that means the sides across from those have to be congruent. So that'd be the side across from this one would be segment CD. and it's got to be congruent to segment EC. Got to be able to use your imagination and separate things off and redraw it. I don't redraw it up here in this way just because I like drawing stuff because I'm not very good at it. That's what you have to do to figure out this stuff. Find X. If all of these angles are congruent to each other, then this triangle has to be equilateral. So that's 60 degrees, that's 60 degrees, that's 60 degrees. We really don't need to know that. What we need to know, if it's equiangular, then it also has to be equilateral. So if this side's 12, then that means this side over here has to be 12 and x equals 12. This triangle is equilateral. That means it has to also be equiangular, so all these angles are congruent. The only way that works is if x is 60, if all the angles are 60 degrees. Next one, find x and y. I'm looking at this, and again, I'm just going to start finding stuff that I know. I know that these three angles are the same. Well, this is a triangle, and it has to be an equiangular triangle, so that angle has to be 60, that angle 60, that angle 60. If that's the case, then all three sides also have to be the same. Well, if this side's 40, then that means this side over here has to be 40, and they told us that it was 8y, so 8y has to equal 40. We can just solve that. Divide by 8, y equals 5. That's one of the answers that they wanted. Then I look at this other one. If this is 60 degrees, this angle right here, because they make a straight angle together, has to be 120. We look at this second triangle down here, this bottom one, and we know that this side was 40, this side was 40, and this first triangle, and it was equilateral, so that means this part right here has to be 40. Well, then the bottom triangle, this is 40, this is 40. We know this angle is 120. Well, these two sides are congruent, so the angles across from them have to be congruent. Well, if this angle up top here is 120, then we just take 180 minus 120. That leaves us with 60. And if these two angles have to be congruent, all we got to do is take that 60 and divide by 2, and we end up with this angle right here, x equals 30. Find the perimeter of the triangle. Remember, perimeter is the distance all the way around. So we got this sandwich here, and we're trying to find the perimeter of it. The distance all the way around the whole sandwich. They tell us that these two angles are congruent to each other. Well, if those two angles are congruent, then these two sides have to be congruent. So x plus 4 has to equal 4x plus 1. And we just solve that, subtract x on both sides. We end up with, these cancel out, 4 equals 3x plus 1, subtract 1 on both sides. Those cancel out, we end up with 3x equals 3. Divide both sides by 3, we end up with x equals 1. Now to find the perimeter, we got to plug that back in and find the lengths of all the sides. So I'm going to plug in 1 right here. And I get 1 plus 4, well that's 5. So this side over here is 5. Well, if that side's 5, then this side over here has to be 5 also. And then to find the perimeter, I'm just going to add them all up. I got a 7, I got a 5, and I got another 5. That equals 17. And since it's perimeter, it's just whatever units we started with, it was inches. So the distance all the way around this sandwich is 17 inches. That's your assignment, page 330, 6 through 15, 20 through 23.